Hello, I'm Shishin, and I'm going to do a simple discussions about the concepts and examples in calculus. Let's start. First, in part 1, we will talk about the cost, revenue, and profits. As example, I'm owning a company that sells car. For each car Rm 50,000. The cost of producing one car will be Rm 35,000, and all the machines that produce car costs Rm 2 million. So the cost in these situations will be the total amount of money that are needed to pay to produce a certain amount of car. So it will be 2 millions plus 35,000 x. And the revenue will be the money I earned after selling a certain amount of car, which is 50,000 x. The profits will be the net money I earned after selling cars. So we need to subtract the cost from the revenue to know how many money I actually earn. So in these situations, it is going to be 15,000x minus 2 millions. So if in the same situations, if I sell 1,000 cars, I substitute the number into the equations we have just now, and I can find out that the cost will be 37 millions, the revenue will be 50 millions, and the profits I gained will be 13 millions for selling 1,000 cars. Then we can talk about the average cost, which is we divide the cost functions by x, the total number of items sold. So it can be used to find how many products are going to produce to reach the minimized average cost. Because the first derivative of the average cost functions, we set it to be 0, then the x will be the number of products we want to find, and it minimizes the average cost. So in this example, let's the cost functions of a products be 30,000 plus 3,000x plus x squared and 1,000 units were produced. Find cost and average cost. So the questions already give us the cost function, so we just substitute 1,000 into the cost functions to find out that how many money we need to produce 1,000 units. And for the average cost functions, we just divide it by the number of items to find out that how many monies we need to produce 1 unit, which is Rm 4030. Find how many units should be produced to minimize average cost. So just as I said before, we need to know the first derivative of the average cost functions first. So in order to find this, we can find the average cost function first, which is dividing the cost functions by x. We get the average cost functions. And after applying a first derivative and some simple calculations, we find out that x will become positive negative square root of 30,000. In this case, we will choose the positive one because we are going to find the items, the units of items are going to be produced, and it's not going to be a negative number. So we choose the positive one and round out to up or down to a closest integer because it should be the units of items that leads us to the minimum average cost. So this is just to repeat what you just said just now. We just plug in the number we get just now, 173, into the equations of average cost. So it should tell us the minimum average cost we can reach, which is in this case will be Rm 3,346 and 41 cents per unit. So about the average revenue, the same, we just divide the revenue functions by x. But since revenue is already the price times number of item, when we divide it again by the number of item, it just gives us the price or the price functions. Yes, price can also be equations because in most cases, the mathematics questions just give us a price and tell us to find something else, but in real world, price can vary differently because it is inverse. It is affected inversely by the growth of supply. So in this example, we can see that although both of them are fishes, but the bluefin tuna is much more expensive than the Atlantic salmons just because the number of bluefin tuna is very rare in the oceans, so it's hard to find. So the supply decrease, price increase. So this example let the price functions to be 5,000 minus 25x. What is the revenue and average revenue if 75 items were produced? So as we said just now, the average revenue functions is just the price function. So just substitute 75 items into the price functions and get RM 3125. And the total revenue is just the multiplications of the items, number of items, and the price. So we just multiply them and get the total revenue. And as the same way, the average profits, we just divide the profit functions by x, which is the number of items sold. In this example, the profit functions will be negative 2.5x squared plus 1000x minus 1000 and 500. Find the profits when 100 products were sold. So when the profit function is given, you just substitute 100, which is the number of products sold, into the functions and gets the answer. B. Find the average profits per unit. So we divide the total profits by the number of units sold to get RM 735 per unit. For the changing rates of profits when 100 products are sold. So talk about changing rates, we need to apply first derivative to the profit functions and let it to become negative 5x plus 1000. We substitute 100 items into the equations and find out that when we sell 100 products, the changing rate is actually increasing in a positive RM 500 per unit. Then we move to the second part, which is the washer method. From this image, we want to find the volume of the bounded area when it rotates around the x-axis. From our observations, both of the functions form a cone when they rotate around the x-axis, a big cone and a small cone. To find the volume bounded by them, just subtract the volume of the small cone from the volume of the big cone. Then we will get a hollow cone which represents the bounded volume. When we cut it, we will have a slice of washer-shaped disc with a hole in the middle. This disc will have a certain width of dx. When we sum up all the volume of the disc, we obtain the bounded volume. To do this, we should have known the formula for area, which is pi r squared. Plug in the functions into the formula to get the area for the outer disk and inner disk. Subtract the area of the inner disk from the outer disk, and then we can get the area of one washer. Then multiply by the width, which is dx, to get the volume of one washer. To obtain the total bounded volume, perform an integrations that's supposed to sum up all the volume of every washer. Finally, we get our total volume, which is 4/21 pi. Last of all, we've entered the third section that talks about the moments and center of mass. The moments of an object is the mass of its multiple by its distance from rotations. In this example, M1 will be 50 kg meter and M2 will be 32 kg meter. And since M1 is heavier than M2, it's larger, than M2, the system will decline over M1. So if we want the system to be balanced, we need to find the locations of center of mass by the formula total moments about the origins divided by total mass. In this example, the total moments will be 50 plus 32. the total mass is 8 plus 10. This gives us negative 18 or 18, which is negative 1. This means that the fulcrum needed to be moved to the left for 1 meter to balance the system. All of this is just the solutions for one-dimensional system. But how are we going to deal with two-dimensional questions? Introduce y-coordinate of center of mass, which works very similar to the x-coordinate of center of mass just now. Remember, the x1, x2 in x-coordinates refer to the distance from the y-axis, and the y1, y2 in the y-coordinates system refer to the distance from the x-axis. We only have two variables in this case, but there can be more variables than this, such as m3, m4, m5, and more. But if you're still using the same equations, this should work the same. After knowing this, it will be very easy for us to complete this example. We just substitute the mass and coordinates for both the loads we have here into the formula. We will get the x and y axis for the center of mass, which is 2.8 and 3.2. And that's all from me. Thank you for watching and listening for the whole video.